Hello and welcome to chapter 2.2, solving two-step equations. The objective here is to solve two-step equations. And I will be talking from normal from now on. Here's what your thinking process should be when you're solving two-step equations. It's kind of like one step, except it's just in two steps instead of one. So again, you first want to see what is the math shown, and you have to do the opposite. But you have to work backwards from PEMDAS. This is very important. Make sure you write this down. Backwards from PEMDAS, that means you do any adding, subtracting, then you do any multiplying, dividing, and then any exponents if you have them. Let's get started. First, I have to see what's the math here. I have both multiplying and I have adding. So then I have to think, what's the opposite of adding? Because you have to get rid of adding first, and that's subtracting. So I'm going to subtract on both sides. And since I want to get rid of this 3, I have to subtract 3. So on the left-hand side, I still have 2x, and on the right-hand side, I now have 12. Now I have to get rid of multiplying. So the opposite of multiplying would be dividing. So I'm going to divide on both sides, and I want to get rid of this 2. So I'm going to divide by 2 on the left-hand side, and whenever you do on the left, you have to do on the right. So x would be equal to 6. When you have two-step equations, it's very important that you should check your work to make sure that it works out. So 2 times 6, because you got x equals 6, plus 3. What does that equal? Well, 2 times 6 is 12. 12 plus 3 is 15. So it checks out. Yay! This one might look harder, but it isn't. The first step is always, what math do I have? Well, I have dividing and I have subtracting. So again, you always want to get rid of adding, subtracting first. So I'm going to rewrite the problem. So I won't need to add to both sides because that's the opposite of subtracting. And I want to add 3 because I want to get rid of my 3. Remember, whatever you do to one side, you have to do to the other. So I have 8 on the left-hand side is equal to t divided by 2. So now I look at my dividing. Well, the opposite of dividing is multiplying. So if I multiply by 2 on the right-hand side, then I have to multiply by 2 on the left-hand side. These two will cancel. So on the left, or on the right, I just have t, and 2 times 8 is 16, so that would be my answer. Again, you should check your work. So if I have 16 divided by 2 minus 3, 16 divided by 2 is 8. 8 minus 3 is equal to 5, and it checks out. What? This one is a little more confusing. There are 2 ways to do this, and I'm going to show you both ways. You should pick one or the other. The first way is to rewrite the equation so that it's just subtraction. So on the left-hand side, I rewrote the problem so that I am dividing by each term. So on this side, I have division and I have subtraction. So the opposite of subtraction is adding. So I want to add 7/3 to both sides of my equation. Remember, when you're dealing with fractions, though, you have to have a like denominator. So this would be negative 36 over 3 plus 7 over 3. And I still have x divided by 3 is going to be equal to a negative 36 plus 7 will give me a negative 29 over 3. Now I have division right here, so the opposite of dividing would be multiplying. Whatever I do to one side, I have to do to the other. So x will be equal to, the 3's would cancel out before multiplying, so it would just be negative 29. That is one way to do it, and I would say a lot of people don't like that way just because of this step with the fractions. The other way that you could do this is, you should always do adding, subtracting first, unless if there's a large division bar, like so. So I still have division and I have subtraction. When you have a large division bar, you can get rid of that large division bar first. Remember, the opposite of dividing would be multiplying. So I'm going to multiply both sides by 3 over 1. These 3's will cancel each other out because because it's multiplying this whole section. So I'm just going to have x minus 7 is going to be equal to negative 36. And now I plus 7 to both sides of my equation, and I get x is equal to negative 29. Either way you do it, you get the same answer. Right now you should pause the slide and try this equation by yourself, choosing one of the two ways. You should have gotten that x is equal to 26. I personally like to get rid of the huge division bar first, so I multiply by 4 on both sides, and then I added 2, because the opposite of dividing is multiplying, the opposite of subtracting is adding. You do not have to justify each step, but this one is a little trickier because of this variable. You should rewrite that, and whenever you see a negative, you should write that as a negative 1t plus 8 is equal to 3. Now I see that I have both multiplying and adding, and the opposite of multiplying would be dividing, and the opposite of adding is subtracting. Remember, you should always work backward from PEMDAS, so I'm going to first subtract 8 from both sides of my equation. So I have negative 1t is equal to negative 5. So since I'm multiplying, the opposite of multiplying is dividing, and I want to get rid of this negative 1, so I'm going to divide by negative 1 on both sides of my equation. So now I have t is going to be equal to a negative divided by a negative would become a positive 5. You should pause right now and see if you can do this by yourself. Make sure to do the opposite that's shown and work backwards from PEMDAS. You should have gotten that x is equal to 27. The first step you should have done was add 5 to both sides of the equation, because that's the opposite of subtracting. And then you should have multiplied by 3 on both sides of the equation, because that's the opposite of dividing. You should pause and you should attempt to work on these problems. I will be going over these problems at the beginning of class. Have a wonderful day.